So if any of you still have problem, okay, any parts that you go through during our break, cannot understand, you can ask now, right? Anyone? Any questions? Before I continue again. Anyone? So far so good. Okay, so I will continue. Variance. Okay, as I mentioned just now, the short form is VAR. VAR, and then in fact, this variance and standard deviation, ST. So this is number 3 and number 4. Basically, they are related one. So number 3 and number 4, they are related. Okay, why I say related? Because the standard deviation actually is the root mean square deviation between the individual values and the mean in the distribution. So this is what I have explained just now. Root mean square deviation between the individual values and the mean. If you remember, as I mentioned just now, remember this is the normal curve. This is the mean. This is the mean. So let's say if I have x1 here, I want to find the difference between the x1 and the mean. Deviation means different. How do you calculate the difference? You minus, right, everyone? How you want to find the difference between x1 and the mean? The value, individual value means the x1, the x2, the x3. This is your individual value, one by one. You want to find the deviation, the difference is you take the minus. How to find the difference? You minus x1 minus the mean. So x1 minus the mean. Then x2 minus the mean. Let's say x2 is here. So you want to find the difference. Then again, you minus it. x2 minus mean. 1 by 1 minus. Okay, and then this is the explanation using raw data. Again, we start with raw data. So consider a set of population data with x1, x2, x3 up to xn. We do care, maybe 10 data or 20 data or 100 data, or even can be millions of data. Doesn't matter. So what we want to know is the population mean. Okay, and as we know that variance is actually the root mean square. What's the meaning root mean square? Okay, here, the population standard deviation. So take note, everyone, the symbol and the name. This is called sigma. I use this word sigma, S-I-G-M-A. This is something like a B crooked one. Everyone, you see this symbol? This is called population standard deviation. So remember, population is the big group. Because we are talking about the mean, remember this mu is your population mean. Remember just now I mentioned. So we're talking about big group. Therefore, when you want to calculate the standard deviation, we also use the word population standard deviation. I use the short form, standard deviation, right? STD, standard, DEV means the deviation now. Okay, so everyone, I hope I want everyone to remember the symbol. As I mentioned, if you remember the symbol, you don't remember the name, no use. Like you remember a person's face, you know your friend's face name, but you don't know the friend's name. Or you know the friend's name, but you cannot remember their face. You cannot remember the symbol. So for statistics, you must remember the name and the face, the symbol, both together. Everyone know what I mean, right? Okay, so look at the raw data first. So for the population standard deviation, this is called, can everyone put here, there's a square root. Can everyone add this one? Square root. It's called root mean square of the x minus the mean square. Square means you square. So you need to square all this, as I said. Square this, one by one. And then you total up. Okay, total up. So we put here summation, divide by n. So all this divided by n. Then you total up, one by one. So that's how you get the formula out. Now, if you don't want to use this formula, you see the word all here, right? So if normally in our calculation or in exam, in the test, whatever, I prefer to ask you all to use this formula. This formula is much easier compared to this one. You may ask why? Because this one you calculate one time total x squared, every of the x is squared, total up one time divided by n minus this one is your mean. Total x divided by n. Everyone, do you still remember this is your sample mean? Total x one by one, you total up divided by n. This is your sample mean. Then you square it. You can get your population standard deviation. Compared to this one you have to do one by one. If I have 10, 20 data, you minus one by one until from the first one, x1 to xn. Are you going to do like that? No. Unless you have computer or software to do for you. So my suggestions are, everyone, you use this formula in our calculation, tutorial or test and so on. It's much easier. Okay? So we have a choice here, right? Okay. Now, so this is for populations. Next, we go for sample. For sample, remember, this is called sample mean. Everyone, take note. Just now is mu, right? Now we use what? X bar. Okay? And standard deviation we get, we call it sample standard deviation. Just now it's what? Population standard deviation. We use the sigma. Now we use what? Sample standard deviation, and the symbol we use is S. So you see, I use a different symbol. The normal S is the sample standard deviation. Okay, sample means the smaller group. Remember chapter 1, we learned that. Okay, now the formula we have, again, you can take the square root of each of the x minus the sample mean, square it, and then one by one total up, divide by n minus 1. Again, this one is not easy because this one you have to take one by one individual data minus the mean. So it's very tedious. Unless I have 3 or 5 data, okay lah. If in exam I have 8, 10 data, the time you take to calculate one by one is definitely longer. So because of that, we have another formula, or see the word or, we have another formula to calculate the sample standard deviation, like your population standard deviation. So the alternate formula is this one, given by square root total x squared, same thing. All the x individual data you square it, total up, then you minus this total of the x first, calculate all the x, total up, one time, square it. Take note, these two are different. Yeah, divide by n, then divide by another n minus 1. So take note, these two are different things. This is total up all the x, then only square it. This one, each of the x is square it, then total up one by one. Okay, we are going to do exercise using formula so that everyone can be very sure the difference between these two formula and these two formula for population and for sample. So I circle this, means we are going to use that. This one, up to you. You want to use it, make sure you have enough time and make sure your calculations, use calculator all carefully. Okay, next, variance is the square of standard deviation. Just like I mentioned, variance and standard deviations are related. How they are related? Variance is the square of standard deviation, meaning that standard deviation, ST, when you square it, square is like that, right? Bracket square, and we get equal to what? Variance. Understand? Standard deviation value, we square it, you get variance. In other words, if I don't want the variance, I take square root of variance, I will get back what? Standard deviation. Correct not everyone? Mathematics now. Square root variance, you get back standard deviation. Can? So everyone remember this. So the question asks you to find standard deviation, you calculate variance, and then you square root it. That will give you the standard deviation. Okay. Now this is raw data, everyone. Raw data don't have frequency. Am I right? You see your formula here. There's no F, no frequency one. But if you have a group data, then second part. So let's do the example first for raw data. When you come to group data, you have another 4 formula there where you can see the frequency. Okay, so let's do some exercise now for this raw data. Find the standard deviation and the variance for these 5 simple data. N is 5. Okay, now we want to calculate the this one is what? Okay, everyone, there's always an argument, always question raised by people. How we know whether there's a population or sample? How we know? How we know it is a sample or population? Some of you will already want to ask me how we know it's a sample or population, because you got 2 formula there, right? Sample and population. So in the exam, how you know? In the tutorial question, how you know which one? Sample or population? Since they are slightly different formula, right? The answer you get is slightly different one. If you use the wrong formula, you will get a slightly different answer and marks will be minus. So if you ask me how to know which one is sample or which one is population, for example, find this 2, 12, 7, 5, 9, find the standard deviation and the variance. The question never mentioned, right? Sample or population, but how we know? But you see the answer based on what? Population. Then you ask me, there are only 5 data here, right? 5 data, but how come we use population? Then you start to wonder, sample means what? Small group. Population means big group. How come 5 data here, we use population formula and not sample formula? So listen carefully, everyone. If the question never mentioned sample or population or any hint, if there's no hint, if there is no hint, you know hint means what, right? Tips are use what? Population. I will explain to you with more example what's the meaning called hint. So in this case, they never mention sample, they never mention what? Some, they never mention the word few. Okay, so you see, sometimes the question mentioned that some question is mentioned selected, a few. All this means what? Some students, selected students, a few students, all this refer to sample. This is the hint I mentioned here. If the question, see this one, never mentioned about the hint, so we use what? Population. Anyone don't understand? Okay, very good. So we use population. So you want to find population variance, like which formula we use? So we look at the population, look at the variance. So we find this out. We find the standard deviation, and then you square it out. That will give us the variance mark. Oh, so we use this population standard deviation. This is your sigma. So we have to find the total x squared and the total x. Okay, so what's total x squared? Now, total x squared means you take each of the x2 square plus 12 square plus 7 square plus 5 square plus 9 square, 1 by 1 square, it total up to 303. Then your total x is 2 plus 12 plus 7 plus 5 plus 9, 35 lah. Okay, so you put into the formula there. What's the formula? This one, right? As I said, you need to square it because standard deviation, square it to get variance. So you square this. So this one no more square. Follow everyone. Total x squared is 303 divided by n is 5 calculator minus the total x, which is 35 divided by n also 5 squared it. Okay. When you use calculator, you get 11.6, right? You can try now, everyone. So to find the population, after you get the variance, you want to find standard deviation. What do you do just now? You square root, right? Here. You square root the variance, you get back the standard deviation. So you square root 11.6, you get 3.41. No? Try not, everyone? Any questions? Anyone want to ask anything before I go on? Everybody clear what is populations and what is sample? We are talking about raw data now. Okay, group data later. Okay, next. So this is the hint. This is the conclusion. If there's no hint, use population. So everybody okay with this? Don't use sample. Now, how we know there's a sample? Okay, let's look at one example. During a summer month, the number of central air conditioning is sold by a random sample. So I add in here, if the word use sample, if the question mention the word some, selected, a few, all this using what? Sample formula. You already mentioned here sample. So use what? Sample, standard deviation, or sample variance. Okay? If you use population, minus mark. Everybody okay? Okay, Dong Sheng say, explain again one more time. Everyone listen carefully. How we know whether we use sample or whether we should use population? If there's no hint, hint like the question mentioned the word sample, mentioned about some, selected, a few, okay, all these are words that show that we are referring to what? Sample. If they don't mention, the question never mention all these, then we use what? Population. Example, this 5 data, they never mention, just find the standard deviation and variance. They don't give us the hint here. So we use what? Population. Even though only 5 data, everyone. Okay, even though only 5 data, we still use population. Some people, they confused. They thought of if the data very small, they use sample. If you talk about few hundred, few thousand, then they use population. It's not like that at all. So the conclusion here is we have to see whether this hint, the words given or not given, then only we can conclude, is it a population or sample? Because the argument is, even though we have 5 data, it could be this 5 data is only the 5 in that group, which is the population already. You understand? So the group is very small, 5 only, and that 5% is also representing the population already. So we have no choice of use population. Unless if you have talk about a few hundred salesperson doing air condition, and then you choose a random sample of 5, maybe out of a few hundred salesperson, then the tips is given, the hint. So this is using sample. Okay, Dongsheng. Others clear? So when you do your tutorial, do your quiz, or do your past question, always check the tips, the hint word. Don't get confused, or don't get how do you call it? We call it cheated by the questions, which is unfortunately lah. So what's your N here? 5. Can someone tell me what is your total X and total X square? So let's look at the sample standard deviation formula. This is your sample, so the S formula. Same thing, you have to find the total X square, you have to find the total X. So can someone tell me what is total X here? Is this 44? X square? 418. Okay. So agree, everyone? Sample variance. So we find variance first, we use the square. Or when you want to calculate standard deviation, we square root it. Okay, this is the formula, right, everyone? Here. So can you all calculate for me? X square is 418 minus total X, which is 44, square divided by N is 5, then divided by N minus 1, 5 minus 1. Calculator? $7.7. Am I right? Yeah. So clear, this one, enough explanation, right? Okay. Check these words. Group data, okay. That's why I mentioned group raw data, there's no frequency. Raw data, you already know, right? There's no frequency table, no F. You have done so many exercises already. So for raw group data, you can see also the same population standard deviation. We have sample standard deviation, it's the same. The symbol we use is also the same. Can you check this? There's an error here. Sample we use S. This one change to S. Can you all change this to S? So for group data, the population standard deviation, we still use the sigma here. Now you see the formula slightly different from the group data for raw. For the raw data, you see this one? There's no F here, right? Because raw data no frequency one, but for the group data, there's an F there. That's the difference. And then this is your total F. The total F is actually our N. Remember? N represents all the items. So in this case, our N here actually is our total F. Why not? I mentioned before. So for the sample one, S, the formula is also similar to the raw data. You see now everyone compare this formula, there's no F, right? Right, raw data, but the group data, there is a F here. So again, this one, N minus 1. N is your total F. So I can write total F minus 1. For group, but for raw, we use N minus 1. Okay? Can, so I can write here the small n is total F also. Whether it's population or big N or small n, is the same total frequency. Okay, can we do one quick exercise here? Find the mean and the standard deviation. And remember, in chapter 2a, we have done the mean. Yes or no? So I need everyone now. You have to do your revision now. On and off chapter 2a and 2b, because they're all related. Okay, if you've forgotten any parts, you cannot proceed to do the rest. For example, now you want to find the standard deviation. You need to go back to your chapter 2a, find the mean for this group data. Okay, 0 to 6, 6 to 12, and so on. This is your frequency. So what I suggest, like what you have done in your chapter 2a, remember we built this table, right or not? So this is your class limit, this is your frequency. To find your first thing, is this talking about population or standard deviation? Don't see the answer first. Is this sample or population? Don't see the answer. Can someone answer me? Don't see the answer first below. From this question, find the mean and standard deviation. Mean, sample or population? Kenfu, Kiaman, yes. Izan, others? The answer is population. Why population? Don't tell me you see the answer here. Population, why? Because it's never mentioned. The word sample, some selected, a few. So we have to use what? Population. For the mean and also for the standard deviation. So mu and sigma. Let's find population mean. Total fx divided by total f, chapter 2a, everyone. So what you need to do, you must find the class mark. The right amount x. Anyone forgot about this? How to find class mark? Upper plus lower, 0 plus 6 divided by what? 2. You get 3. 6 plus 12 divided by 2 is 9. Okay, for each of the class. So that is your x. And then you need to build one more column, f times x. 2 times 3, 6. 4 times 9, 36. Can I give you 5 seconds? Fill up this. And then you need to build one more column here, fx squared. Fx squared. What is fx squared? F times x times x. X squared means x times x. So you take fx, 6 times x again. 6 times 3 is what? 18. 36 times 9 is 3 to 4. That is what it means, fx squared. F multiply x again. So you take this x and fx column, multiply again to get fx squared. Why we need to calculate this? Can someone tell me what's the total here? Why we need to calculate fx squared here? Because of the standard deviation population formula. See this one here? This is the fx from here. Can someone tell me the total? And this is your fx squared. After you calculate all, total up. This is for this one. Yes, what is the total here? Still calculating. 792 Encate is for which one? 792 is for this one. Okay, so find the population mean, total fx divided by f. 792, your total frequency here is what? 40, right? 792 divided by 40 is 19.8. Any questions from anyone? Okay, total fx square, right? 18072 Ang Xiao Hui. Encate. Okay, 18072. Anyone don't get this? So that is for your population standard deviation. So the mean you calculate here, 90.8. The population standard deviation, this is the formula here. Okay, total fx squared, which is the 18072 divided by total f is 40 minus total fx divided by f. Everyone, can you see this? This is actually our what? mean. Right not? So 792 divided by 40 is actually 19.8 lah, or square root. So you divide minus, you get 59.76, right everyone? Then square root is 7.73. This is your standard deviation. Remember, square root. So no hint, use population. Unless the question mentioned, find the mean and standard for the following sample of what, or a few selected what. Then you know there's a sample. Okay, everyone. Anybody cannot follow? I hope my explanation not too fast. You can find your friend to do group study, especially when you enter campus. Find your friend to study together, but follow SOPO. All right. Another good example, the output distribution for some workers in the Z company is given by this. Calculate the mean and standard deviation. All right. Don't see the answer, everyone. Is this sample or population? Answer me. Yunting, Yiqing, Xin Li. Wow, so many. Dongsheng, Kiaman, Eng Li. All right, others? You don't see the answer, you already see the what? The word some of the workers. Now, the workers can be many, millions, few hundred, but we only select how many here? How many? 100. Say 100 total. It could be millions. We only select some. So anyway, the word hint here tell us is a sample. The question will give you one, but be careful. Sometimes they won't give you the tips very directly. Everyone listen carefully. They won't tell you the word sum or sample very directly. They write the tips, the hint in the questions one. Whenever you read the questions, be careful. It's very tricky. Tricky means you cannot determine easily. So in your quiz, in your test, you all have to be careful. So second thing, this is group data, and you can see this is what? There's a gap. Now, to find the mean, I told you, right, class limit also can be used as class mark, because class mark, class limit and class boundary can be used without closing the gap. Remember, I told you class mark, no effect. You close or don't close the upper. You still take upper plus lower divided by 2. Even you want to plus minus 0.5, everyone, remember you minus 0.5 here. You can use this also. You try and see. You take this one plus this one divided by 2, also get 23, 28, and so on. So there's no difference for class mark. Okay? But I suggest if, as I told you, right, I worry some people always very confused easily. So I think you can plus minus 0.5 if you want to so that you can use this to get the class mark. Also can. Can someone tell me what's the total effects here? 3425 divided by total of frequency is 100. Now remember everyone, if you find your class mark wrong here, x, your fx also wrong, fx squared also wrong, because everything depends on the x. So your marks will be deducted. fx squared, Sample standard deviation, this is the formula here. Sample standard deviation, this one now. Fs squared total minus total Fs squared divided by total F minus 1. So we have 1, 2, 0. I suppose this is the answer, isn't it? Minus Fx 3425 square it divided by n 100. Okay, divided by n is 1 and minus 1. Anyone can give me the answer? Just give me the final answer. Will do. Hmm. 8.24. You can put 3 or 4 decimal point. Okay. Now, just before we go off, everyone, can we spend some time? So everybody already know how to calculate the mean or standard deviation for raw data and also group data. You have to check whether that is sample or population. Okay. And then before we stop, we look at one more part, CV. This is number 5 here. Coefficient of variation number 5. So what is CV actually? CV actually is, we want to compare the variability between 2 or more different distributions. Okay, now we're talking about 2 different set of data. So the only way to compare the relativity between 2 or more distributions, the best is we use a relative measure. When we talk about relative measure, we change it to what? Percentage. Because if we have different unit, if we have different unit, so let's say we talk about 2 sets of data, one in kilometer, one in kilogram. Very hard to compare. Different units, very hard to compare. Example, kilometer. Kilometer is the distance. Compare with kilogram. Kilogram is the weight. Can we compare kilometer and kilogram? Everyone? Cannot, right? Kilometer is for what? Distance, how far, kilogram is for what? Weight. So we cannot compare different units. So what we need to do? Change all to percentage. So the relative measure of dispersions is dispersion measure expressed as percentage. That's the best. The commonly used in your subject here, the easiest way to compare in percentage is using coefficients of variation, which is called CV. The formula, everyone, you have to remember standard deviation divided by mean. You already know how to calculate standard deviation, cannot. So you just have to check whether it's a population or sample. Then you divide by the mean times 100%. Can I give you an example? Set data 1, set data 2. The standard deviation is 27 kilometer. This is in unit kilometer. Set data 2, the standard deviation is 4.6. This is in ringgit. This is distance km. This is money. Can we compare? We cannot compare. This is distance. This is money. So we cannot compare. And then the mean also 454 km. Or in km. This one also in ringgit. 10 ringgit. So we cannot compare. Cannot compare RM with kilometer. Ringgit Malaysia is money, kilometer is distance. We cannot compare. So we change to what? Change to percentage. And how to change percentage? Find the CV. Use this formula. Standard deviation. So you see, based on this, how do you get Let's calculate. Standard deviation is what? 27, right? Everyone can check. 27 divided by mean, 454.5 times 100%. You get 5.94. You see, the unit, when you change to percent, unit no more already. All change to what? Percentage. Correct or not? Same as set data 2. 4.6 ringgit, standard deviation, you divide by 10 times 100%. So the ringgit no more already. You get what? 46%. Also in percentage. You see the two data now all in percentage, same unit. When the same percentage, you can compare. How do you compare? Distribution 2 are more variable. This is your comment. You write more variable than distribution 1 because 46% is higher than 5.94. So you see, whichever higher percentage, you can mention that the distribution are more variable than the one that which is lower. Or we can say that distribution 1 is more consistent than distribution 2. Whichever has lower CV, so you write down here, lower CV means higher consistent. You write down here. You see, distribution 2 is more variable than distribution 1. And I say that if the data set has lower CV, it means that the consistency is higher. So either you write like this, more variable data 2 than data 1, or you can write data 1 is more consistent than data 2 because the data 1 is lower CV also can. Both way you can comment. Can everyone? So this is the last measurement of dispersion that we can use to compare between two sets of data, especially they have different units. Can Now, just before we go off, let's look at one more example. Give me 2 more minutes, Aaron. Type A can type 40 words per minute with a standard deviation of 5, while another typist, you know typist, right? The person who type 160 words per minute with a standard deviation of 10. So which typist is more consistent? Now, remember, more consistent means the CV must be lower. The question asks more consistent, so you must check which one has lower CV. So you find the typist A and typist B, CV. So for typist, CV for typist A, okay, what is the mean? 40. The standard deviation is 5, right? So 5 divided by 40. Use this formula. Yeah? Times 100%. So we get 12.5%. CV for typist B. Okay, typist B can type 160 words. Then the standard deviation is 10. So 10 divided by 160. Standard deviation divided by mean times 100 is 6.25%. Correct enough? So the result shows that typist A percentage is higher, right? So has more variable than typist B. But the question say which one is more consistent? Typist B. So typist B has more consistent in terms of their CV in her work because the variation is lower. So lastly, when making comparison, rule of thumb is the larger the percentage, the greater is the variation, lesser consistency. So I write the summary here. The larger CV, larger percentage, the variation is also greater I put the arrow up means what? CV percentage higher, right? The variation also higher, but the consistency lesser, mean drop. Okay, if the CV percentage is lower, the variation also lower, but the consistency go up lor. That's why I see typeface A has more variable than typeface B, but the typeface B has more consistent in the work. Fair enough. Logic, ma. Any questions? Okay, that's your tutorial 2B. You can finish all this and present to your tutors. This is all the final answer. Okay, discuss with your tutor if any questions. So that's all from my side here. Anyone want to ask any questions? I will stop the recording now. Everybody okay? So I will see you. Lim Zihui, you asked me the college not open. Okay, anyone if have any comment, with any comment, can you talk to faculty, or even to the person in charge. So I'm not sure who is in charge now. Maybe it's the student representative. You can ask your parents to call in or whatever, because we know that there are many parents call in now. You can talk to faculty. So we as a lecturer can't comment very much. We also have to follow. So if you have any students worry about the COVID and so on, I suggest you all have a platform, okay, between the parents with the UC and so on, or you can even call the faculty and ask their advice. Okay. Other than that, if we don't have any latest instructions, we still have to follow by next week. Everybody enter campus. If there's any changes, the UC will give us the latest instructions. So far, no, right? Everyone, we never heard anything, right? So if you still have any worries, you can talk to faculty or UC. Until no further instructions or notice, we have to go back to campus. So everyone stay safe. See you all next week, Monday. Where is our lecture? DKD, isn't it? You know where's DKD, everyone? Do you know where's the lecture hall? Or are we supposed to do the online? Lecture still hybrid or online? Because
I think it should be online.
Online, isn't it? Because I heard there's a comment that in the beginning they say it's online, but after that I heard there might be some SOP for hybrid, or even though for lecture also. So anyone heard anything? Lecture is hybrid or fully online? So far I haven't heard anything after Chinese New Year. Class rep, can you all update me? Go and check around. I also will check with the CC. She will update me, but so far no news. We still have 3 more days to go to. Kasin say what? Hybrid. I mean the lecture or not the tutorial. I mean the lecture. Hybrid or fully online? $200 of you here, right? 200 of you. If you all go for the DKD, so you have to stay safe. Make sure you wear your mask. Christy, what is your question? I will check with the CC after this and the faculty. Oh, you mean the lecture also, Kasim? Okay, so if confirmed, then everybody please follow the instructions, lecture also, like the tutorial. Any news we update in the classroom. Okay, don't worry about that. So any more questions? If not, I will see you next week. Tutorial as usual. Okay, take care everyone and do your tutorial to be. Okay, bye bye.